My name is Ivan Zoratti. I'm the Chief Product Officer for FogLAMP at Dynamic Systems. You see another name here, Mark Ridosh. Mark is here virtually, meaning that you will see there will be a video that we will run as a demo, and he has prepared this video for us. Unfortunately, we could not really show things live just because of audio and video issues we may have for internet connectivity, etc. So the presentation today is introducing FogLAMP, and you see also the title down here, Open Source Platform for the Internet of Things. So let's see what it is. You may have already attended another presentation we had Monday. Did anybody attend that presentation? Nobody? Oh, okay, good. Here we are talking about the development side, or if you want, the more technical side of FogLAMP. But let me start. First of all, let me introduce you to Dynamic Systems. We are a startup based here in the Bay Area, in an office in Menlo Park. The mission is super simple: simplify IoT data. Of course, simple to say, very, very complicated to achieve. Dynamic comes from the Greek dianomi, which means distributed or distribution. And we refer to the distribution of services, of data, of everything that you can see in the world of IoT and IIoT. This is really the way we think. We believe, really, we can simplify projects and services around IoT and IoT data. So you have probably already seen this slide in other presentations, and they're all wonderful keywords. I want to highlight two of them that I think they are really, really important for us: open systems and community. And I'm going to explain in the first introductory slides what that means for us and why we believe it's so important for IoT and IIoT. The agenda today, very quickly. We will have a brief introduction about the fog computing and industrial IoT, and then we dig immediately into FogLAMP. What is FogLAMP? The architecture, some of the use cases, and as I said, we will have a demo and then a little bit of info, of course, regarding the roadmap. But by talking about open source projects, a roadmap is always something that is made by the community. We are the captains of these open source projects, but it's really the users, the developers, whoever wants to use and contribute and help in improving the project that can dictate and can help with the roadmap. So let's start from some very, very basic concepts. You may wonder, okay, what are the challenges in the Internet of Things, and more importantly, in the industrial Internet of Things? This is just a combined set of concerns that we have gathered from different surveys, from Morgan Stanley, HP, Gartner, but also others, like Cisco had other surveys, etc. Security is definitely one of the most important elements. Security concerns is probably number one or top three challenges. But also lack of standardization. Standards that are known standards for the very simple reason that there are so many. There are like hundreds, if not thousands of standards, and the result is nothing is really standardized. So the integration of all these elements, all these components is so difficult that it makes an IoT or an IIoT project overcomplicated. And it shouldn't be like that. I mean, what we want to do, of course, is to have relatively simple ways to implement and integrate all the components and all the elements, hardware, software, services in an IIoT project. But then we also have lack of skills. And it's not because maybe the people you have in your organization are not experts, but they are experts in a certain area. And there are so many areas that you need to combined together for these kind of projects that you always end up with more skills needed, and also clearly high costs and more time spent on this project. I'm not going through all of these, so in detail, but let's see clearly, since we are talking about an OSI soft conference, data is the most important element. So data integrity is another important challenge here. And data security again. So all of these plus many, many others, I'm sure that you may add others that you already know and you see yourself as other bullets we should add to this list of challenges, are number one priority for people who want to work in industrial IoT and they are involved in IIoT projects. Now, there is an attempt, let's say, to find a solution to these challenges by standardizing IoT projects around an infrastructure that goes beyond the typical concept of cloud or edge and cloud. And this is really what we refer as fog computing. If you don't know, well, who knows about fog computing or have heard of it or they maybe have read something about it? Okay, very, very few people. I saw only 2 hands, well, three hands. So actually, that's interesting. So fog computing, first of all, we have a talk. There is another talk this afternoon regarding the architectures of fog computing and why it's so important today. But fog computing is, just to make it very, very simple, this concept of the multi-layer infrastructure where you should be able to collect and use and consume data and resources where they are needed. I'm making this super simple. Of course, it's much, much more complicated than that. But just to give you an example, you have at the very low level, as you can see in the slide, the endpoints where you have the things, and these things must be, from one side, controlled, from the other side, they generate data, that generate information that we may want to use. And we may want to use this data right at the edge. For example, if we are in a driverless vehicle or on a drone, or if this data is specifically generated by this thing, it must be probably used also inside this thing as well, or at this layer with other systems that are combined together. But you may also need to send this data or this information up, as we say, up north, to middle layers where we have gateways or maybe we have more sophisticated nodes, going up to bigger data centers or to the cloud where we have cloud servers. And this is basically what fog computing describes. To some extent, you combine the power of the cloud and the way cloud systems are organized, and you bring some of the architectures and philosophy around the cloud down at the edge or in any layer wherever you need this kind of architectures. I think it will make more sense by showing you, in examples, and with FogLAMP that will be hopefully more clear. There is a consortium that has been created 3 years ago. It's the Open Fog Consortium. Well, the name says it all, right? It's related to fog computing, and the idea is to define standards for fog computing. And these standards must be open. They must be really embraced by everybody. There are something like 68 companies who are part of the consortium at the moment. OSI Soft is definitely, clearly one of them. We are part of the consortium, but we also have companies like Intel, ARM, Cisco, Dell, VMware, etc. So there are many, many. The whole point is to define the architecture that will be the future architecture for industrial and non-industrial IoT projects based on this idea of multiple layers and multiple components with the consumption of data and resources at any level, wherever you need them. And these architectures are based, as a reference, on 8 important pillars. You see them here: security, scalability, openness, autonomy, etc. Again, in the presentation on fog computing that we will have this afternoon, we will go into the details of this. Here I'm just setting the background, and then I will explain why we have created FogLAMP and why FogLAMP is the way we've done it. So with this in mind, with the fact that there is a reference architecture, there are standards, new open standards that we are defining, and hopefully they will collect all the requests from the end users and what the providers can really build. We thought, okay, what is the way, let me go back here, what is the way to create something that is really open and can really help everybody in working on IoT and IIoT projects? Well, my personal background is from open source. I worked with open source software, and I've been involved in open source projects since 2003. So it's 15 years now. Wow. And I've seen how open source literally changed the world from the internet to the web and down to now IoT. And everybody is using open source, even if you don't know that, even if you think that you're maybe working on commercial software, I'm sure, I guarantee you that there is open source software in any library that maybe as a developer you're using, or in any software that you are using. And I'm using now on this laptop, for example, from Microsoft or from other companies. And the way open source can solve this problem is by making the software so ubiquitous and available to everybody, and everybody can contribute, and that's the concept of open systems and community, so that the final result is a constant improvement. And this improvement will be available for everybody. And so step by step, we will have always a better way to implement new projects, more reliable, more sophisticated, and ultimately less expensive and faster. With this in mind, we created a project called FogLAMP. Now, FogLAMP, clearly, you may think, okay, open source, fog computing, that's a great combination. And our CEO, Tom Arthur, had this, I would say, wonderful idea of combining the two names. Well, first of all, FogLAMP is already a name per se, but then you have the combination of fog computing on one side and the LAMP stack on the other side. LAMP stack, which is really the base for the internet, for the World Wide Web, with a combination of Linux, Apache, MySQL, Perl, PHP, and Python. So thinking about a LAMP stack that it changed the way the web and the internet works, we really believe that a product like FogLAMP and the software like FogLAMP can change the world of IoT for good, for better. And so what is FogLAMP? A platform for the Internet of Things, as we said already, and an essential component of fog computing. So we look at the Open Fog Consortium, what are the pillars, what is the reference architecture, and we implement it in an open way, in an open source way. Available for everybody, and everybody can use it, but also contribute, of course, if they want, if they can. It's modular, being distributed and being something that must work at different levels, and on many, many systems, we must have a modular architecture, and this architecture is based on microservices. Now here, if you hear the word microservices, you may immediately think, okay, so he's talking about a virtual machine or a service that is maybe in Amazon or Azure, etc. Yes, but not only that. I just refer to the fact that we have services or processes or computing or resources that are available everywhere in your network at any level. So when we talk about services that run on maybe on small gizmos like this ESP8266, that is not a microservice. That's what I would call a nanoservice if you want to be trendy. But essentially, it's just a thread running on this processor. And the same might be on maybe on an embed OS, on an ARM system on chip, where we may have this service running there, doing something, and I'm going to show you what it may do with FogLAMP. Or if we run maybe on a slightly bigger system, like this is a Raspberry Pi Zero, here we have a a full Linux version running. And here, yes, we do have microservices. We run individual processes, and these processes may run on multiple systems, on multiple Raspberry Pis combined together, connected together. The other important point is that we can run FogLAMP, as I said, everything on this tiny Raspberry Pi Zero, but it also can run on a highly available system. We may have multiple FogLAMPs running together, doing the same things, because it must be highly available. We must have redundancy, and if something goes down, we are 100% sure that the data we have collected or what we are executing on this system is available also on another machine exactly at the same time, and we can fail over to this system. It can be standalone, meaning that it can run in an unattended environment, and perhaps we may have, internet connectivity or network connectivity, or we may work with unreliable networks, or just using time windows where we can transfer data or connect to the external world. So with all this in mind, we thought about FogLAMP. So who are we, Dynamic Systems, with reference to FogLAMP? I used to say we are the captains of FogLAMP. And captain is a quite significant word in the world of open source. It means that the project is pretty much led by us. In a way, we coordinate, but the contribution comes from many, many users and users. And I said customers as a name, as a word, because in the end, we are all customers and providers of the very same project. Names like ARM, clearly OSIsoft, Toshiba, Arrow, Sprint, they're all already contributors of the FogLAMP project. So back to the original slide that I showed you before, right? The fog computing with multiple layers. If we just simplify this into 3 layers, edge, fog, and cloud, FogLAMP can run anywhere, clearly. But the real use case is down at the edge where the things are, where the sensors may be, and in the middle, in a kind of a fog layer where we aggregate data, we combine it together, and usually we have a Pi system at this level, like a kind of intermediate level, or we can have Pi systems even up north. The work of FogLAMP, what FogLAMP does is to integrate all these things down here, collecting data, analyzing and assessing this data, making sure that data is good for what we need to do, perhaps consume the data there, or send it up north to a Pi system, or other systems if that needed. But clearly here we are talking about an integration with Pi software. We already said it's open source, but one very important aspect, if you are a developer and you really care about this, the legal aspects, is available under a permissive license, which is Apache 2 license. So in open source, I mean, some of you may already know that, but in open source there are different kind of licenses. Some are more permissive, others are less permissive. Permissiveness means that if you are developing a commercial software and you want to use open source software, you must check which license you're using. Apache 2 allows you, as a license, allows you to take the software and integrate it into your commercial software, and you're legally entitled in doing that. If you have other licenses, like for example GPL, the idea is that you must contribute back to, it's a must, contribute back to the community with your software. So you cannot integrate it into a commercial product and leave it closed source. Your product itself must be open source as well. So you must be careful with that. But we made it completely permissive because we really want everybody benefit from that. It's written in C, C++, and Python. So it's a mix of different languages depending on the microservices. Some of them are just very simple, and it can be only a few lines of Python well combined together with other more complicated and sophisticated written usually in C. And we have already this platform available on large numbers of systems, on Linux, mostly Ubuntu and Debian, but also on, we have versions on CentOS and Red Hat, and on architectures like clearly Intel or Cortex, ARM Cortex-A and Cortex-M processors. And we can run on very, very small systems. I mean, like, for example, this is an Embed OS board, a development board. We have 128 kilobytes of RAM in here, and we have clearly customized. It's not a fully full-blown version of FogLAMP, but still, it works on here, and it's able to collect data, for example, from this temperature sensor, and buffer the data locally for a little while, and then send it to Pi whenever, of course, there is a connectivity available directly to a Pi system without passing to any other layer. That might be one of the use cases you may have. And we are available, of course, on GitHub, the main repository for open source projects. And we have our own APT repository, which is a repository from where you can immediately download and install the system without any build, etc. So without building it. The architecture is, don't get scared with all the boxes here, because I hope by explaining it, it will be relatively simple. Everything in green is a plugin. So it's all pluggable. You just use what you need, so you don't inflate the whole environment with things that you don't need. And then the concept of tasks and microservices, the difference is just the fact that the microservice is always running and the task starts, it does something, and then it dies, and maybe it will be rescheduled for another running maybe a little bit later. We have the south, north, east, west concept. So down south, you have the south microservices that are plugins that are used to collect data from sensors and devices. In the middle layer, you have a core structure that takes care of all the basic elements like monitoring, check the availability, the scheduling, and the provisioning of the system, but also a storage layer that is used for buffering data. So if you are in a remote location and you don't have data, clearly you need to have something to keep it there until you can finally send it to a Pi system. And then the north side, the one up there, are plugins for tasks and services that are used to send data to a Pi system or to, for example, OSI soft cloud services, etc. If you want to consume the data locally, you may have internal application modules, or you can talk through a REST API, and you can have your own application that can consume some of the local data at the edge. Now, to be clear, this is not something that you use for analysis. We don't provide like an analytical engine or anything like that, but you may have, for example, a snapshot of what is the current status of your sensors or your devices at this right moment. If you need like for example, a time series or a history, what you should do is really to go up north or east-west to Pi, maybe to EDS, an edge data store, or up to a Pi server and check the history in that case. Today we are with what we call version 1.2, which is the first iteration of FogLAMP in terms of release. We started from 1.0 for just continuous integration reasons. And so the architecture that I show you has been implemented in this way. So there is a scheduling and management at the core level. We use SQLite just for buffering, but there are options, for example, to use some other stronger databases. For example, if you need high availability, as I mentioned before, maybe you don't use SQLite, you may use something else like Postgres, for example. And we have a bunch of South plugins that we use really just for showing what you can do. The plugins that are really more important, I would say, are the ones that you may need for your own environment. And provided that the hardware manufacturer has the right library that we can plug in, we can basically connect anything you want. We have a couple of standard protocols like CoAP and HTTP, HTTPS, or CoAP through DTLS. And then you see here the DHT are the standard, really inexpensive humidity and temperature sensors that we show, or the sensor tag are just development boards with sensors. And again, it's just to show what you can do with FogLAMP. Up north, you see OMF and OCS, so the cloud services and the standard OMF, the OSI soft message format to connect to a Pi connector relay, and through the Pi connector relay to your Pi server and asset framework. In terms of repository, and just to give you names attached to what we have done, FogLAMP is the name of the project that you can find on GitHub. Or you can see other blocks and other projects on GitHub hosted by Dynamic, but the name is still FogLAMP, it's not Dynamic. And you will see, for example, FogLAMP-south-sensor phone, which is an example on how you can connect external systems like maybe applications from your mobile phone, or like the PT100 sensor or other things down there. Yeah, let's skip this for a moment. As I said already, we can run on all sorts of different hardware and software. If you have already visited our booth, you may have seen, for example, let's go from the biggest down there. Flash Matrix Toshiba is a huge box that is a number crunching and big I/O system that runs at the edge, and it can execute an incredible number of operations for machine learning at the edge. There are lots of use cases that may be used there. What we can do, we can have our little container into this box that is used to feed this machine with data coming from devices and sensors. There is this number crunching going on at the edge, and then the distilled results go up to Pi. So the plant manager or in the control center, you may see the result of these machine learning operations. Or you can see us on, for example, on smart gateways, smart switches, or on just industrial grade PCs, or on small Raspberry Pis you may want to use for just maybe for development, or sometimes even for deployment. And in terms of implementation, I already mentioned Ubuntu or Raspbian. If you are, maybe some of you may be involved in smart boxes, smart switches, where OpenWRT and embedded Linux systems are available, well, we are there too. I mean, we have standard libraries that we use for FogLAMP, and we have already ported FogLAMP on these platforms. And we are also working, as I already mentioned, on BedOS and the Yocto projects to create, let's say, specific Linux distribution for embedded environments. I mentioned the REST API, so there is also the ability to use some UI if you want. Very basic, but everything is REST-based in FogLAMP, and the concept is quite obvious because of the old distributed architecture. Now, when we say REST, people come immediately to the concept, okay, so REST means HTTP or it means HTTPS. Yes, that's what it means today, but it shouldn't be just like that. We can plug any other protocol that makes sense in a kind of REST connectionless environment that may be maybe more lightweight if you want to install FogLAMP on something that must be low power consumption, and HTTP or HTTPS is not good enough for that. So going down to some of the smart cases, use cases, we have an example of a smart factories where you may already have your Pi servers installed at the plant floor or in the control center, in the headquarters, etc. I think FogLAMP plays a significant role in pretty much all over here to gather, the data together, analyze, and make sure that this data is good enough to be used and not maybe rejected or controlled in some way, and then send the data up to Pi, and then from Pi, of course, you can use it. The whole concept is the combination of data in motion and data at rest. So with FogLAMP, you manage these two elements. You have data in motion constantly. In IoT and IIoT, data always and constantly moves, and you must know where it is, if it's duplicated or just copied and then removed from the previous environment. So you may think about like smart fleets by installing FogLAMP on trucks, for example, and then again sending data whenever there is connectivity to a control center. Or in plants like mines where, again, you may have a remote connectivity and sometimes there is no connectivity if maybe trucks go somewhere where there is no network connection, or smart roads. I mean, you name it. There are all sorts of different options. I want to show you a quick demo that hopefully it will help in in understanding what we have done. So let me...
Hello and welcome to this FogLAMP demo video. Let's start by looking at the hardware we're going to be using today. We've chosen to show you FogLAMP on a Pi 0W, a very small, very low cost Linux machine. To this we've added a sensor board in the shape of an EnviroHat. This gives us a variety of sensors that will provide data to FogLAMP and on to Pi. Let's power it on and see FogLAMP in action. The first thing we're going to do is log into the Raspberry Pi and check that FogLAMP started automatically when we powered up the Raspberry Pi. The first thing we'll do once we've logged in is run the FogLAMP status command. This will tell us if the FogLAMP services are running and the data has been read into the FogLAMP service on this machine. As you can see, there are various FogLAMP services running and there are records already buffered in FogLAMP. These are a result of a previous running of FogLAMP. To see if we get new data coming in, we can repeat the FogLAMP status command and see these numbers change to verify that new records are indeed being read from the sensors. The number of records sent has also increased. This means that data is being sent up to the Pi service. We will see this later in this demonstration. FogLAMP has a REST API that is used by external applications to interact and control FogLAMP. Let's now test that this API is responding correctly by using the Unix curl command to send an HTTP request to FogLAMP. We'll use the ping endpoint, which will bring back basic monitoring data from FogLAMP so that we can see the status via that REST API. We use the JQ command to format the data that comes back from this REST API. We can see here that FogLAMP has been up for a number of seconds and is indeed receiving new data and sending that onto Pi. By rerunning the command, we can verify yet again that the data is flowing in to FogLAMP and up to Pi. We can also use this REST API to view the data that is buffered within FogLAMP. To do this, we'll again use curl, only this time we'll use the FogLAMP asset endpoint. This will give us information about the assets that are currently within the FogLAMP buffer. The result we get back is a basic count for each asset of the number of readings that are buffered within FogLAMP. We can again rerun this command in order to determine that the particular assets are receiving readings. We have built an example web-based user interface that utilizes this REST API and allows us to see the interaction with FogLAMP. Here it's running on a local laptop connected through to the FogLAMP server as before. We can view statistics data and even look at the readings that we have seen previously through the REST API. We have some primitive visualization tools that actually let us drill down and look at that buffer data. This is the data that is held within FogLAMP, which will be sent up to the Pi server. We can use this UI and the underlying REST API to see the state of FogLAMP. This allows us to monitor the service and make sure things are running as they should be. The goal, of course, is to get your data into your Pi server. Here we can see under the OMF North tag in the Elements browser those assets that have come from our FogLAMP service. We can drill into these as with any other readings within Pi and get data, look at the time series and trend information. Once the data from FogLAMP is in your Pi server, it is indistinguishable from any other data that may have been read into Pi. It will, however, remain within the FogLAMP buffer and may be sent to other Pi servers. FogLAMP provides mechanisms by which control can be exercised over how, when, and with what bandwidth utilization data is sent to Pi. This is particularly useful in applications where you have less than reliable connectivity or you have bandwidth constraints due to cost constraints or other issues.
Okay, let me stop here. We have only a few minutes, and I'd like really to talk about a little bit of a roadmap, etc. But I want to really enforce this point. On the North plugin, as I mentioned, we use OMF. What we do, we take everything that can. Of course, there might be a configuration where we can organize data differently, but just as a default, we take everything that comes in. We identify the assets. And these assets, they are all in JSON format, saved in JSON format inside FogLAMP. We build a structure in OMF where we have a metadata, so the definition of what these assets are, and clearly the content, like, for example, for the accelerometer, the XYZ coordinates, etc. We combine everything together, and then we pass it up to a Pi server through the connector relay. It can be in compressed format. It can be, of course, using the producer token in a secure way with a new version that it should be out, if I remember correctly, from OSI Soft. It's been announced as a beta version this week. And by keeping also track of what's being sent and also being prepared in terms of metadata, we can automatically define the structure and feed the Pi server and feed automatically both the data archive and the IF and the asset framework for that, which is quite a significant, of course, operation that you can do directly with FogLAMP. There is, of course, a lot of space for improvements on these in this area, but as in every software, we tend to release software versions. We do our best to do it every 6 weeks. Clearly, we're a small company, and yes, there are lots of contributors, but still, it's a project that, in terms of number of developers, we are in the order of about a dozen developers altogether. So still clearly a quite small team considering the effort we have. For the roadmap, we believe that the most important aspect we need to tackle now is to reduce the storage and memory footprint. For us, it's not enough. We have right now about 80 megabytes of on the full-blown FogLAMP, about 80 megabytes of storage required, and we can run in a footprint of around 50 megabytes. But again, as I said, it's not enough. If we want to run on smart switches, smart boxes, where we have embedded Linux that provides, 128 megabytes of RAM, that's not good. We need to go down, because when you have the Linux kernel, you have the system, of course, running to collect the data and generate and manage all the packets, etc. And then there is very, very little room left for us. So we have to move everything that is now Python-based down to C and C++. That's one of the things to do. We also need to remove dependencies. So we are working hard in defining a base version of FogLAMP that will be immediately and directly installed without any other change or extra work for the developer, installed on a small system. And if you want to add something else, like a new plugin, or maybe you want to use, let's say, a different type of authentication or security, you simply have an extra element that you add by using a different repo in GitHub or a different package in Linux. We have a fully distributed architecture, but we have to do more for having a really fully distributed implementation, because we have some examples. For example, here we have as I showed you already, this tiny thing. This is a Wemos board, mini board with a DHT, with a humidity and temperature sensor. Here we can run a south plugin, and the south plugin can then be connected to the core and the storage plugin to buffer the data. Well, actually, we need to have a much more distributed environment where we can, for example, split even more the core system and the core and the storage system, which is not something that we have done well at the moment. We still need to do some improvements. And we need also to complete the porting on the Yocto project, because it's not there yet, and that will also open, let's say, the doors to the use with, for example, Cisco smart boxes, because Cisco uses Yocto as a main reference. So if you have maybe you work with an 809 or 829 boxes, that's what they use. We are already accepting plugins and contributions, as I already mentioned, some of the big names that are working on that, but we really, really love everybody contributing. And when I say contribution, I don't mean just developers coding. That's part of the whole story, but even feedback, oh, I like it, oh, I don't like that. Can you please work on this other feature? This feature is so important for us. We will definitely listen to you. And clearly, it's not just our decision. It really depends on what is needed, not just by us, but by everybody. And then on the management side, we need to be even more functionality in terms of the REST API interface. It needs to be improved, and we would like to have a control center from where we control thousands, if not hundreds, thousands of FogLAMP installations. That's pretty much what is really all about today. So I hope you can join us and join the community. It's, again, I think a really exciting project. These are the names that we have today who are really working on that. And with this, I think and hope there will be some questions. And let's see. Any question? Oh, sorry, I can't see. I've got just a... Yes, please.
So just to kind of prefix, we're in the power industry, and so looking a lot at the smart grid, so that's kind of, and the edge technologies, microgrids, whatnot, DER, so that's kind of the preference of my question. So we've been working for a while with Duke Energy to develop the Open FMB. So my question is, how has that standard been integrated from an electrical perspective into FogLAMP, and if so, how? And then second question would be, it sounds like you're going from south to north, but have you guys started to look at device-to-device communication for, an example, shutting down a microgrid and connecting it back to the grid? And where are you guys at in that?
Okay, perfect. So first of all, FogLAMP is an agnostic software platform. So we work with any standard that is available, provided that there are plugins, libraries that can really allow us to work with that. So I'm not familiar with these standards personally, and I can't answer directly. But I think that if there are, if it's available, there are some libraries available that we can connect. I don't see any reason to say no, we cannot work with that. The second point, if it's incredibly important, I haven't mentioned the fact that we are bidirectional. The architecture is bidirectional. We were focused first step to go from south to north, because that is what is really usually more relevant, step one. But step two is definitely going back, or across, absolutely. Going across, there are also, of course, security issues that we need to take care of. That's really important. Sometimes we go across through FogLAMP. Sometimes there might be a kind of a identification and then peer-to-peer connectivity. That's another aspect that it's already defined in the architecture but not implemented yet. But definitely a very important aspect. So thanks for asking. Other questions? Sorry, I don't see. So if you have questions, please raise your hand. Okay. All right. Well, thanks. Thank you, everybody, and I hope you enjoyed it. There are other talks. There is a lab if you are interested in knowing more and even put your hands on FogLAMP and some of the gizmos we have, and the fog computing presentation at 2:30 this afternoon. Thanks again.